Hello and welcome to this lecture on method overriding. Inheritance allows you to get everything from the base class. That includes private member variables, methods, any other class definitions you have, everything gets inherited. But can you access that? That becomes the question. Now, overriding hides the superclass method. So this is the concept behind method overriding. Basically, we inherit something from the superclass, but for some reason we don't want to use it probably as it is. I want to use it but in a modified method. So this is where the superclass method can be overridden. Now it provides a new or a different definition for the same method calls that otherwise would have called the superclass methods. Now this is one of the reasons for using inheritance. At the end of the video lecture, you should be able to understand what is method overriding, when to use that. Now describe the rules to follow while overriding. You can't just take a method and say, let's rewrite. There are some rules involved. Now use access modifiers with overridden methods such as private, public, protected, or no access modifier at all, as well as understand the use of @override annotation, which was introduced in Java 1.5. Now, to help the developer write better code. Now, overriding is a concept that refers to saying that I don't want your method, I want to write my own. So we want to rewrite a superclass method. Always inheritance is involved in method overriding. Now the method name, return type, and the parameters must match exactly. So you can't change any of this. Of course, if you change the method name, it definitely is not overriding because it's altogether a different method. If you change the return type though, now there is a confusion over a period of time as which one you are calling. So that's the reason compilers put a break and say, hey, you can't change the return type. And of course, if you don't use the parameters in a same fashion, then it becomes something called method overloading, which is totally a different concept. Now, if the parameters do not match, it's an additional method. So it is also known as overloading of methods. Now let's start with an example of a method overriding. Consider a class called super. Now super here is not a keyword, by the way, it's just a class name. S is in capital letter, right? So this is just a class name. Now I have some function which is named as some method which takes int parameter and it doesn't return anything, it's doing some work. So you can always create a variable called super s1 equals to new super and s1.sum method, that is okay. But if you have a class sub that extends super, at this point in time, the method sum method is straight away inherited to subclass, which means if you create a variable of sub and make it a point to an object of subclass, now you can straight away call sum method by supplying some integers. Now it is going to be the superclass method which is inherited to the subclass. That is the one that is going to be called. However, if I rewrite the same method with the same return type void, same name as sum method, int parameter, now this is called overriding. So if I call that function, it's the subclass function that's going to be called. Now here is another variance of the same, but it's not method overriding. It's called method overloading. We have the same class super and same method called sum method, which is taking int param instead of something else. However, our subclass extends superclass and writes the same method. Void is the return type, sum method is the name which is same as the superclass one. However, the argument is of string parameters. So the parent one is an integer, now the subclass one is a string. Now this is resolved easily because based on the type of value you supplied to call, now that decides whether to call the superclass one or subclass one. So there is no overriding. So subclass objects have two functions called sum method, but which one gets called depends on what parameters you are supplying. Now this is the key to overloading. So we have incorrect return types also. Sometimes if you do incorrect return types, what happens? We have a class super with void sum method, argument doesn't matter in this case, and I have a subclass that extends super. Signature is the same, signature corresponds to the method name and the parameters. However, return type is different. Now, if you look at the class sub alone, there is nothing wrong. You can always have a function called some method and returning an integer. However, compilers have a problem with this. Now, why is the problem? Now imagine hypothetically for a minute you assume that this is okay. And let's create an object of subclass. And I say s1 equals to new sub. And now I have a call to make. So I'll say s1.sum method, and when I supply integer parameter, now compilers could not understand which method to call, because you can always call any method whether it returns something or it doesn't return anything. It doesn't mean that you have to assign it to something. So s1.sum method 10 will give an error because it doesn't know which one to call. There is an ambiguity. Now this is the reason compilers in advance stop you from doing this. So this different return types for the same method signature is not allowed. So there will be a compilation error. It says return type int is incompatible with void. Now that's a message you get. Now let's look at access modifiers in case of overriding. Now while overriding, you always have to take care of this such that the visibility is always increased or widened. Access becomes more stronger and stronger, and that's what you have to ensure. Now there are three modifiers that we generally take care of. One is called package level, one is called protected, and the other one is public. So we say using a package level access is a weaker access, and we say protected is a little bit stronger. The reason is package level members are accessed only inside the package, whereas protected members can be even accessed outside the package provided they are inherited. Public members can be accessed anywhere. So we say package level is a weaker access, protected is stronger, and public is strongest. And that's what we say. So when you're trying to override, you can increase the visibility, you cannot decrease the visibility. For example, if you reduce the visibility, your compiler would give an error. From package level, imagine you have a superclass method with a package level access, and the subclass you're trying to make it as private. Now that's going to be an error. Similarly, if the superclass has a method with protected and you're trying to override with either with a default or package level access or a private, that's going to be an error. Similarly, if a public method of a superclass, you're trying to write it as protected or package level or private, now compiler stops you from doing that. Now reducing the visibility, let's take an example. We have a class called super and it is protected in the superclass. So protected void sum method. Now when the subclass, we are trying to rewrite that with a void sum method, but we make it as private. Now if you say private methods are my own method, now you're wrong, because you're trying to write a method which is accessible to outside world in the superclass, but you are now saying no, it is not accessible. That's something compiler is not happy with. So it's going to give an error attempting to assign a weaker access privilege. Now that is protected already, you can't reduce that. Now the only possibility here is you can make it as protected or public in the subclass. Now let's look at other modifiers such as final. Now final methods means that you cannot override them. Of course, if the final method is there in the superclass. If you write your own methods as final, that means if somebody is extending your class, they cannot rewrite your method. So as an author of a class, you have complete control on what functions somebody can override and somebody cannot override and somebody must override. You have full control on that. Now an object exposes the final method as is. That means if I have written a method as final, now no matter who extend my class, my method will be called as it is. There cannot be an overriding at all. Now by making this method as a final, now it is guaranteed that nobody else will modify the code in their subclasses. Now an overridden method can also be made as final. For example, I inherit a method from my superclass, but I want to override and I want to mark it as final. Now that's okay. A non-final method in the superclass can be marked as final here in my subclass. But somebody who inherits that into their classes, they cannot override. Now that's the rule of the game. So let's look at an example of overriding a final method and what kind of errors that we get. Now you have a class called super. We have a function called public final sum method of void type, and we are trying to override that by writing exactly the same thing. Now that's going to be an error. Compiler says overridden method is final, so you can't really do that. Now that's the whole idea of having it as final. So you can also have private methods in the superclass, but can we override them? Now there is a special rule that applies over here. A private method belongs to the object and not to anybody, including the subclass objects. Of course, if you remember, private members, they get occupied in the memory even for a subclass object, but only thing is you can't access that. But as far as the method is concerned, the method belongs totally to the object of the superclass, and it's never ever available in the subclass at all. It's not exposed. So this way, it doesn't even exist for the subclass. So the overriding is a concept only if you see that method in the superclass and then I'm trying to override. That makes sense. But since private methods are not accessible, not visible, they don't exist for a subclass, you can always go and say, hey, now I don't have this method, I can rewrite. So overriding doesn't apply to the private methods. You can rewrite them, you can override, you can write even a different return type also. All these are possibilities. So let's take an example. Now superclass has one private function called sum method, and now subclass is extending superclass and trying to write a method, and note that this time public int sum method. Now if you see on the fly, you might think that okay, this is supposed to be an error because int sum method, whereas in the superclass it is void sum method. So ideal cases this would have been an error, but if you look at the access modifiers, in the superclass it is private, so it is as if that doesn't exist for the subclass. So which means this is okay. It's altogether a totally different function. It's not even overriding at all. What about static methods? Now you need to know static methods belongs to the class, not to the objects. So a static method in the superclass, if you override, now you cannot mark it as a non-static in the subclass. It has to be marked as a static. So that's very much important. Now this is one of the important reasons because a static method typically called using a class name. However, in Java you still have that leniency to call that using an object's reference. Now in languages like C# that is not even possible. So which means there is a compilation coming into picture and giving an error. But here, because there is a variable can call a static method, now what if you have one static and one non-static method with the same signature, and that's why it is not allowed. So Java says you have a static method in the superclass, it must be written as a static itself. Now this is going to be an error because you're going to say overridden method is static, so you really can't do that at all. Now the same rule applies for a non-static method, which means if a method is exposed as a non-static in the superclass and you want to override that as static, and that is not allowed because a non-static should be overridden as non-static, static should be overridden as static. And that's the rule, so we can't really do anything about that. Now let's take a look at an annotation called @override. Now annotations generally act as instructions to somebody, like a compiler or a tool like a Java doc, or probably for a runtime too, or even for a framework. So the annotation @override indicates that a method is intended to override something from the superclass, but is it done correctly or not? Now this was introduced in Java 1.5. In fact, the whole concept of annotations came in 1.5, and it is targeted on a method. When you write an annotation, you typically place it for a class name or a variables or methods, constructors, and so on. Now this particular annotation is only used along with a method. Now this is going to be written only in the source code, which means in the compilation compiled output you won't have this, which means it can't give you instruction to the runtime or frameworks and so on. Now instructs the compiler to check if the method that I'm overriding, is it following all the rules that we discussed so far. In the superclass, does it exist with the same name, same signature, same return type, static, and all those things. So do take care of that. So that's what is the intention here. Now from Java 1.6 onwards, now this annotation can be used even for an implementation of an interface method. And 1.5, it's applicable only for a superclass subclass relationship. Now let's take a look at an example. We have a class called super and we have a public void sum method. Now note the capital M in between, which is a good practice that we follow for what's called as a camel caps, and that's something that we need to observe here. Now we are trying to have a subclass, and a subclass extends superclass. And we do have a function here, public void sum method, and note the small letter m for method. Now what do you think is going to happen? Do you think compiler would now give an error because you're trying to override with a spell mistake? No. The compilers will not worry about this because the first function in the superclass is one, second method in the subclass is a second method, totally different one. Compilers have no problem. It will treat the subclass method as a new one and absolutely no problem. But you might, as a developer, you might think that I have overridden this particular method, and when you try to call some method, it's going to pick from the superclass because the subclass method had a different case. So you have to call it with the exact same case. So it is now not acting as an overriding. Now this is a kind of a logical mistakes people do, and over a period of time Java guys realize that okay, there are certain places where you can make Java more robust, and at override makes this more robust. So let's look at this now. So we have a class super and it has a sum method as in the previous case, but this time we do have a type mistake still now, but with the @ override you try to compile now, and the compiler will now give an error saying that hey, you're trying to override a method called sum method with m small letter, but that method was not found in the superclass, so this is an error. So methods are wrongly. So that way you know that there is something wrong that I'm doing. In fact, the IDEs like Eclipse will give you, as soon as you're typing this itself, they will give you an error. So you know that okay, you are not overriding, there is some logical mistake that took place. The error message you get is method does not override or implement a method from the supertype. Supertype could be an extension or implementation of an interface. So let's quickly summarize what we have learned so far. Now, overriding of methods enable us to redefine an inherited method. Generally, the whole idea of inheritance is code reusability, but not that exact same code. I would like to use 90% of them, but 10% of them I want to probably add new and modify. So when you want to modify, overriding is the concept to follow. Now, you can increase the visibility of an overridden method, but you cannot decrease that. Meaning, you can only increase from protected to public, package level to protected or public and so on, but not vice versa. Now, final methods cannot be overridden, and @override is an annotation introduced in Java 1.5, instructs the compiler to verify if method is really overridden or is it probably a logical error.